Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Uthman bin Azlan. My metric number is AN200109. I'm from Group 5. So this is my group member, Abdul Muin bin Abdul Rahim, Muhammad Uthman bin Azlan, Khalid Saifullah bin Ibrahim, Muhammad Abid bin Rosdi, Muhammad Fahim bin Isa. So I want to present about crypto programming project. Okay, move to first part, which is introduction. This presentation explores cryptography through three fundamental techniques, which is Virginia cipher, left binary shift key, and reverse cipher. This technique offers essential insight into encryption and decryption algorithm, enhancing our understanding of information protection and security. Gaining hands-on experience and practical knowledge about encryption will help us appreciate its significance in today's digital landscape.
Assalamualaikum and good morning. My name is Muhammad Qayyim bin Isa and my metric number is AN200010. Today I will present about Vigenera cipher coding. So this is the coding that we use in Vigenera cipher. So next. So the generator function takes a key, a character and a length as input and return a list of potential key. It counts the number of occurrence of the character in the key and generate a new key by appending the specific numbers of time. Next, the Vigenera function accept a message and a key as input and return either the encrypted and also or decrypted message. If the key does not contain the character Z, it first creates a list of all possible keys. The function then iterates through the message, retrieving the corresponding character from the key for each character. And lastly, the function either encrypts or decrypts the character based on the encrypt variable value. The, the main function prints the program's name and prompts the user to indicate whether they wish to encrypt or decrypt a message. The user's message and key are obtained and the function called Vigenera with the message and key as parameter. The output is the encrypted and decrypted message. So this is the flowchart for both encrypt and decrypt. So the first for encrypt, it will display the binary cipher group 5 and enter the text. Next, enter the encryption key and it will display the encrypted message. Next, for decrypt, it will first also display the Vigenera cipher group 5. Then the user will enter the text. Now it will ask, do you have the encryption key? If no, it will display sorry buddy, need more information than that. And if it's yes, just enter the encryption key. Then it will display the encrypted message. So this is the result from the coding, and from the example it will display the hello world and the key for encryption is Soya. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Muin bin Abdul Rahim. So I'll be explaining on the left or right binary shift key encoding, or the other name for it is the Caesar cipher. Alright, so as you can see from this coding, we've already made 46 lines worth of coding. So the explanation will be on the next slide. Alright, for the Caesar Caesar cipher. So the code defines two functions. Number one is the Caesar encrypt and Caesar decrypt, where the encrypt function is for the encryption and for the Caesar decrypt is for the decryption. So the Caesar encrypt function accepts as input a text and shift a value and returns the encrypted text. It creates an empty string named encrypted text. It then looks through each character in the text. It determines if each character is an alphabetic character. It determines whether there is lowercase or uppercase. If lowercase, it adds the shift value to the SC code to the character modulo 26 and appends to the result of the encrypted text. If it's uppercase, it adds the shift value to the SC code modulo 26 and adds 65 to get the encrypted character SC code and return to the encrypted text string. This is the loop function where it adds the modulo 26. The difference is if it's the uppercase, it will add 65. If it's lowercase, it is not, but then it still refers to the SC code. Then the Caesar decrypt function is similar to the Caesar encrypt, but then it performs decryption. So it's almost the same. But then for the decryption, to obtain the answer, it subtracts the shift value rather than adding it. Alright, so this is the flowchart for the Caesar cipher. Alright, number one, user interaction. So choose E or D. E for encryption, D for decryption. So if we choose choose E, get text from the user, which is the input. Get shift value from user, whether you put from 0 to 9, the value. And then encrypt using the Caesar encrypt function, and it will encrypt the result. And then if you choose D, it will get text from the user, get the shift value from the user, and then it will use the Caesar decrypt, and then it will get the result from the decrypted text. So that is pretty much the flowchart for the Caesar cipher, or the left or right binary shift keying. And lastly, this is the result from our exe file or our executable file. As you can see, enter E to encrypt or D to decrypt, and then I press E, and then I enter the text Muirahim, and then enter the shift value, negative value to the left, positive value to the right. So I press 6, and then it shifted to the right, where the encrypted text is SAOTXGNOS. That is the decrypted text that was gained from the Caesar cipher. So that's all from me for the Caesar cipher. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abid bin Rusdi, and my matrix number is DN200-103. So moving to the next part, which is reverse cipher. So this is the coding that we use to get the result for reverse cipher. So next we go to the reverse cipher explanation for the coding before. So the first function, reverse cipher, takes a message and returns the message in reverse order. It does this by creating a new variable called reverse message and assigning the reverse version of the input message to it using the syntax message. Next, the second function, which is main with parenthesis symbol, is where the program starts. It asks the user for a message, stores it in a variable called plain text, and then calls the reverse cipher function with the plain text as input. The reverse message written by reverse cipher is stored in a variable called ciphertext. Finally, the main function displays the ciphertext. And last but not least, after displaying the ciphertext, the program waits for the user to press enter before it ends, using the input with parenthesis symbol function. So next we go to the flowchart of reverse cipher. So this program start with read user input, then process call reverse cipher. Next, define reverse cipher, and then the input of this program will define reverse message using slicing, and then the process continue with return reverse message, and we'll get the input, which is store return value in ciphertext, and last is print reverse encrypted and ciphertext. So next is result of reverse cipher. As we can see, the reverse encrypted shows the reverse word from the origin that user put, which is hello world, and this is the result for this reverse cipher. So that's all from me. Thank you.
My name is Khalid Saifullah bin Ibrahim. So my material number is CN 2074. So for conclusion, so in conclusion, study in Virginia cipher, so left or right binary shift keying and reserve cipher provide a foundation for understanding encryption concept and their implication in data security. So this encryption approach help us grasp the fundamental principle of encryption and emphasize the significance of key management. So however, considering their limitation, it's become evident that stronger encryption techniques are necessary to ensure the privacy and integrity of sensitive information. So that's it. Thank you.